So today we're talking about rotations, okay? And a rotation is a transformation that rotates every point in the pre-image about point P, called the center of rotation, by an angle measure x degrees, called the angle of rotation. And you always assume this rotation is counterclockwise unless you're told otherwise. Alright, and this is the notation that we use, the lowercase r, and then a subscript of a number to a degree. So that's what you're rotating about. 60 degrees, 100 degrees, whatever. And then the point you're rotating about. Okay? We typically will rotate about the origin. Okay? But it can be whatever point you choose to rotate about. Your angle of rotation is the angle through which the pre-image is rotated from the image. The angle which the pre-image is rotated to form image. Okay, so this right here is 100 degree counterclockwise rotation about point P. So you do a lowercase r, and then, and yours may be uppercase, is it? Okay. Lowercase r, and then x degrees, comma P. So whatever degree, so this would end up being 100. So you're going to do a lowercase, and then 100, comma P. Because we're going to go 100 degrees counterclockwise about P. Right? Now, when we do this, I'm going to kind of show you, like if we were to do it manually, what happens. We're not going to actually do it manually because it's very tedious, okay? But I'm going to show you what's happening, okay? Let's take point L, for example. This right here is the pre-image for point L. This is the point of rotation, okay? And then this is the image, all right? So, when you rotate, you do this at every point. You draw a line segment from the pre-image point to the center of rotation. Then, with the protractor, you would measure 100 degrees. And then you would take this same length from L to P, and you would draw it to L prime. So these two distances have to be the same. Now, the picture's not the greatest. One line looks longer than the other, but that's what has to happen. So you draw a segment from your pre-image to the center of rotation, you measure 100 degrees, and then you draw that congruent segment to L prime. Then you would go like you would do M. Okay? You would draw a segment from M to the center of rotation. You would measure, again, 100 degrees, and then you would do a congruent segment from the center of rotation to M prime. And those would have to be. And you would do that for every point. And if you did it for every point, then you would create rigid motion. Your pre-image and your image would be indistinguishable. They would preserve length of the segments and measure of the angles. Okay, if you did that for every single one of them. If you got off a little bit, then it becomes skewed and the image becomes distorted. Okay, so you have to rotate everything 100 degrees, and the pre-image and the image point has to be equidistant to the center of rotation. Okay, now like I said, we're not going to actually do this by drawing it, but that's what happens. Okay, so these rotation has coordinate rules just like your reflection did. So you've got to be careful not to mix them up. You've got to come up with a way to remember it. Alright, so we have 90 degrees counterclockwise rotation. And so yours has a capital R, you need to change to a lowercase r. Right? We were doing reflections at the time. So change all those capital R's to lowercase r's. Everybody do that, because I want your notes to be right. Okay, so this is a lowercase r for rotation, capital R is reflection, lowercase is rotation, 90 degrees about the origin. So you take your x and your y coordinate, you change the sign of the y coordinate, and they switch places. Okay, that's the rule for rotating 90 degrees counterclockwise. So change the sign of the y and switch. Okay, so let's look at that one. Okay, here is A. We want to map it onto A prime. Okay, the rule is you change the sign of the y, make it negative, and they switch. So then A prime becomes negative 5, 4. And so that achieves a 90 degrees counterclockwise rotation. Notice that from A to the origin and A prime to the origin, they're equal, and they create a right angle with 90 degrees. Okay? So that is what's happening. Now, how do I remember this? Okay? The way I remember it, regardless of what the point is, in my brain, I picture a point in the first quadrant. Okay, I just picture the first quadrant. If I'm going to rotate 90 degrees, I have to cross over the y-axis. So that's the one that changes sign. And then they switch places. Okay. All right. The rule for 180 degrees counterclockwise. Now, honestly, 180 degrees counterclockwise is the same as 180 degrees clockwise, right? Or half circle. So, a rotation of 180 degrees about the origin, you take your x and your y and you change the signs of them. Okay, they don't switch places or anything, they just change signs. Alright? So, if this is 4, 5, then it should come, and it should make a straight line, okay? Equidistant to the origin is going to be negative 4. Negative 5. Negative 4, negative 5. Now, think about this. When you talk about signs in your coordinate plane, these are always both positive, yes? So if you go 180 degrees, these are always both negative, yes? This is always negative, positive, and down here is positive, negative, right? So you're actually, going from one quadrant to a diagonal quadrant, right? And so the signs are going to change. That's how I remember that. Okay. All right. And 270 degrees counterclockwise. Now let's go and talk about this. 270 degrees counterclockwise and 90 degrees clockwise is the same thing. Okay, let's look at the picture down here. See, if I go 270 degrees, that's the same as going 90 degrees clockwise. Okay? So it can be written either way. But the rule for both is you change the x-coordinate and they switch places. So you change the x-coordinate and they switch places. And if you're going to do 90 degrees clockwise instead of 270 counterclockwise, the 90 has a negative in front of it because you're going in the opposite direction. Okay? So if you're going to write it like that, it's negative 90. But the rule for both is you change the sign of the x and they switch places. So, change the sign of the x and they switch places, which make it 5, negative 4. Yes? Yes, you are. Alright, now how do I remember this one? Again, I put myself in the first quadrant. Okay? Now, 270 kind of goes almost all the way around, not quite. But remember, it's equivalent to negative 90. And if you do negative 90, you cross the x-axis, and that's what changes. So it's just the opposite of the positive 90. Okay? And the positive one, the y changes sign so they switch. And the 270 or the negative or the 90 clockwise, the x changes and they switch places. Okay? Alright, so let's do a few examples. Rotate the trapezoid FGHI 90 degrees counterclockwise about the origin. In your homework today, I want you to at least write the correct notation for the rotation. So remember, it's a lowercase r, and then you have a subscript, and it's 90 degrees counterclockwise, so 90 comma about the origin. Okay, so minimally I want you to write that. Now, for us, we're going to write the rule 2 just for right now. And what's the rule for 90 degrees counterclockwise? Negative yx. Negative yx. So we're going to go through here. We're going to do negative yx. So you change the sign to y.
Negative 7, negative. I mean,
What'd you say?
negative 6.
Negative 7, that's right, yeah. G prime would be
Negative 2.
negative 2, 9. H prime is negative 2, 3. And I prime is negative 7, 5. Okay, so let's graph those. Negative 7, positive 7. That's F prime. G prime is negative 2, positive 9. And H prime is negative 2, positive 3. And I prime is negative 7, positive 5. Alright, so 90 degrees counterclockwise about the origin. Okay. Rotate the quadrilateral WXYZ 180 degrees counterclockwise about the origin. Now remember, counterclockwise and clockwise for 180 degrees is the same thing. So, when you do the lowercase r, and it's 180 about the origin. And what's the rule?
Negative x.
Negative x, negative y. Okay, so we change the sign of both of them, so it becomes 1, negative 8, 0, negative 4, 2, negative 1, and
4, negative 3.
4, negative 3. Alright, so you go to the right one, and now 8. There's the prime. And up. I did that wrong. Oh yeah, I was looking at the wrong one. 0, negative 4. I was looking at this one and that one. Wait a minute, that's not right. Okay, so 0, negative 4, and then 2, negative 1. There's y prime, this is x prime, and then z prime is 4, negative 3. Alright. Now I've rotated 180 degrees about the origin. Okay, 270 degrees counterclockwise about the origin. Again, it's a rotation of 270 about the origin. Remember, that's the same as 90 degrees clockwise. If you wrote that, you put a negative 90 there, so 270. Okay, so you take your x and your y, and what happens? Y and x change signs, right? And they switch places. Okay? So, A prime would be 0, negative 9. Change the x and switch. Negative 7, negative 6. Change the x and switch. And what happens here?
Wouldn't the 7 be?
When you change the x and change the x sign and switch. Okay, what happens here? 0, 0, because we're rotating about the origin, right? So if you're rotating about the origin and you're using that as a point, it's not going to go anywhere. Just like when you reflect over a line and the point lies on the line, it's still on the line, right? Okay. Alright, so let's graph these. 0, negative 9. There is my A prime. And my B prime is negative 7 and negative 6. And negative 7, negative 3 is my C prime. And my D prime is the origin. Okay, so we graph it. And that's 270 counterclockwise or 90 clockwise. Alright, so you're going to have to know these rules, just like you're going to have to know the rules for the reflection. Translation's easy because it tells you what to do, right? But the reflection and the rotation are easy to get confused. So my suggestion to you is memorize them. As soon as you get your test, write them down. So write them on your hand, or your wrist, or your shoe. Write them test as soon as you get it. You can remember it for 5 minutes. Okay? Alright. Now, you remember the other day when we reflected over parallel lines. Do you remember what happens when you reflect twice over parallel lines? What do you get? A translation, right? And it's twice the distance between the parallel lines, yes? Okay. If you reflect over intersecting lines, you get a rotation. Okay? Now here's the book's definition. Here's my picture. Okay? Now this is actually a clockwise rotation, but it works clockwise, counterclockwise. See how I have my heart, and I reflect it over P, and then I reflect it over Q. See, A maps onto A prime, and then A prime maps onto A double prime. You actually get a rotation. You see it? Okay? Now, the angle of rotation is always 2 times the angle that you reflect over. So I reflected over the 75-degree angle. So the rotation is actually 150 degrees. Okay, you always double the angle that you reflect over. If, let's say, I was going to start here, and then I reflected to here, and then I reflected to here, what would the rotation be?
Because 75.
I know, this is 75 here, you're right, but we're looking reflected over this thing.
Oh.
Huh? Not 180. What is the angle measure? What is this angle measure? 105, right? And so if I reflect it and I reflect it again, it's coming with Q and then P, is going 210 degrees, right? Okay, you see the difference? Okay, because with the hearts, I went over the acute angle, right? With my X's, I reflected over the obtuse angle. You see the difference? Okay, and so that's why the two numbers were different. Okay, now here, I mean, this picture here that they show you, here is your rotation, right, from A to B. That's X degrees, right? So again, we're going from A to B, right? So they're showing that they reflected and they reflected again, and they wrote it as the smaller angle half the angle of rotation. I wrote it as the angle of rotation is 2 times the angle created by the intersecting line. It's the same formula, okay? It's just a rearrangement of it. I just find it easier to say the rotation is 2 times the angle that it reflects over. That's what I think that's easier to understand. But that's the equation for both ways. Okay. All right. So looking at this one, find the angle of rotation for the rotation that is a composition of a rotation. That should be capitalized. Right. Because it's reflect and it's a reflect, right? Yeah. So those should be capitalized. Okay. I think I copied that, but maybe not. Maybe I typed it. So it reflects in and it reflects in, right? What do you do first? You do in and then you do in, right? So we're going to reflect here and then we're going to reflect here. So we're going to end up over here, right? What would that angle of rotation be? It's reflecting over 116, but what's the rotation?
116.
Huh? Yes, 116 double then, which would be what? 232. 232. And this, you reflect it, here's going to be your A prime, and your A double prime is going to be down here. So we're doing this number, right? This, we're going over the 116 degree angle, and so you double that, right, for your rotation. Now, what if I gave it to you like this? Let's say I had a rotation of 120 degrees about point P. Okay? Rotation 120 degrees about point P. If I were going to do a reflection over 2 lines, how should the lines intersect? Like if I was going to take, this point right here, okay, and I was going to reflect it, and then I was going to reflect it again. I want a 120 degree rotation. How should these lines intersect? At 60 degrees. Right? Okay, because if you reflect it and reflect it again, you would double it with the 120 degree rotation. So the angles have to intersect at half of that. Okay. Alright, any questions? Alright, now I want to show you one more thing, and I just want to show you this because don't erase this. I'm just going to use this space here. Okay, and one of your questions is it talks about the line y equals x. What does the line y equals x look like?
It's diagonal.
It's diagonal. Okay, what's the slope of it? 1. And what's the y-intercept? 0, right? So it goes through the origin, right? And it has a slope of 1. Yes? Rise 1, run 1. Okay, so, the line looks something like that, right? Okay, when you draw that, what does it do to the angle created by the rays YW and Y, by the x and the y axis? It bisects it, right? Okay, so when it bisects it, what does it make the measure of each one of those angles? Half of what? Half of 90, right? So this would be a 45 degree angle, and that would also be a 45 degree angle, yes? Okay. Same thing with y equals negative x, yes? It bisects it, right? So instead of having 4 right angles, you have 8 45 degree angles, yes? You might need that for